You're sad.
Okay.
Can I get a drink of water?
Yeah. Alright. Yeah. If you haven't already started your bell work, make sure you're starting bell work.
Okay.
So obviously for the recording. If you need to pause, you can pause now. Yeah.
I need to take the quiz.
What is this? We can do that.
It's stuck and I have multiple.
At the end.
It would get stuck and I have multiple staples.
What did you do to my tab? What did you do to my pencil?
Everyone be.
Serious?
Alright, let's go over the bell work. If AC is 4x plus 5 and DC is 3x plus 8, find AC. What do you need to do first?
Huh? Right.
No.
Well, we already know that AC equals at 4x plus 5. Oh, are we just going to put an equal sign?
Yeah.
Why? Why are you putting an equal sign?
I don't know, I just guessed.
Because you're finding the distance.
I'm finding the distance. What about these marks right here?
Means
They're equal to.
It means they're equal. So when you solve this,
That's 1x plus 5 equals 8.
subtract 5 from both sides.
5 equals 8, x equals 3.
X is 3, which
So,
means that AC
equals.
oh, my board's off. Oh well. 4 times 3 is 12 plus 5 is 17. Good job. Okay?
Good.
Questions on
Oh,
that?
I forgot. Yeah.
Angle FCA is 40 degrees.
FCA. Alright, that's 40.
Find FCD.
So it's an obtuse angle,
here
so it
to
has
here.
to be more than 90.
You guys are already feeling miserable.
140.
Can we listen
It's 140.
Is it recording?
Yeah, it's recording.
Miss
Molly
Newman is the
I like turtles.
Same.
And you're done.
This is the best commentary.
Luke,
What? You telling me to shut up when you guys were screaming? I like cheese or something.
what?
Alright, so how do we find FCD? Garrett, you said 140. Why?
Because there's 140.
Because
Or
the entire
180.
thing is
180,
180.
yeah. And 40. 40. 40 equals 180.
Measure
Is that right?
FCD. Yes, it is 140 degrees. Cool. 3 and 4 have nothing to do with the picture. If you have endpoints at -4, 5 and 6, -2, find a B. What formula am I going to use?
You're going to use distance.
Distance formula, okay? I'm going to call this one x1, this one y1. We'll call this x2, y2. Does it matter which one you call 1 or 2?
No.
No. Great. So distance formula, remind me.
It's the radical sign.
Huge radical.
Negative 6 minus -4 to the same power. Plus.
Y2. Okay, so x2 minus x2 minus x1 squared plus
-2 minus 5 to the same power.
y2 minus y1 squared. And we'll simplify. Do what's in the parentheses first. I know I didn't leave myself a lot of room here, but what's 6 minus -4?
Positive 10 400.
And -2 minus 5. -7 squared. 10 squared is 100. 7 squared is
Positive
49. I don't have room to write it.
Okay.
Is that simplest radical form?
No.
Yes.
No. No.
Does this factor at all? I don't know.
No, it
Bad
doesn't.
it does.
It doesn't?
It could,
does.
probably.
We will figure out.
Like 7 and something. No, it doesn't.
Oh no.
I tried everything, it doesn't work.
What happened to my pen?
I tried everything and it doesn't work. Okay.
Well, I tried 3, 7, and 3.
I'll try the calculator and see what it gives us. Yep, that's it. It does not factor.
Told you.
Woohoo! So that's your answer. That is simplest radical form. Okay? Using the same endpoints, let's find the midpoint. How do I do that?
It's divided by 2, so it's x1 plus
Therefore,
x2
plus
There you
6
go.
divided by 2.
And then y
Comma.
y1 plus
y1 plus
y2.
y2 divided by 2.
Yeah.
Okay. So add your x's divided by 2, add your y's divided by 2. -4 plus 6.
positive
Positive 2 divided by 2.
1.
5 plus negative 2.
3.
3 divided by 2, we'll leave it at 3 halves. Or those of you that don't like fractions, 1.5.
Yay.
Okay? Questions on how to work? Right. Awesome. We didn't have homework yesterday, right?
Nope.
No
No,
homework?
we
nope,
took
so-
the
Yeah,
test
quiz.
thing.
We
The
had a
quiz?
quiz. Yeah. Okay.
Wait, so when are you gonna start the recording?
I'm
Oh,
sorry.
no.
Yay, writing. I love
You
writing.
did the bell work too?
Oh no, I have to
Wait,
put
wait,
pencil.
All right.
Can I say hi to them?
At the end.
Okay.
The point was out.
I don't know, 'cause-
Today's topic. Perimeter, circumference, and area in the coordinate plane. This is why we spent an extra day on midpoint and distance formula. Okay? Your essential questions: how do you find the perimeter of rectangles and squares and the circumference of circles? And what formulas are used to find the area of squares, rectangles, and circles?
That's a long.
I know, there's long EQs.
Huh.
Okay. If at any time you need to pause the recording, please feel free to do so.
Wait.
That's not for you guys.
Can we pause it?
We can
We
pause
can't
time.
pause
Can we pause it?
I wonder how many likes we'll get this.
This is gonna be the next viral video.
Yes.
I'll subscribe.
Remember last year when Mr. Janicek made a YouTube video and everyone kept F11ing it? Like everyone in the class, so we just got hundreds of views in a couple minutes.
What's F11 in here?
It like refreshes the page, but it counts the view.
That's
Oh,
awesome.
that's
Everyone
cool.
in our class was doing that, so we're like, whoa, your vid's going viral.
All right. Perimeter and area are things you have dealt with. What does perimeter tell us?
It's the outside.
It's the outside, so it's the distance around a figure, yes? Or the sum of the lengths of its sides. Sum means, what do you do? Add, subtract, multiply, what does sum mean? There you go, sum. So, sum of the lengths of the sides. So you add up all the sides. Did I have? Nope. Okay. So if you were to find the perimeter of this rectangle, you would add all the sides, right?
C.
Yeah. So let's throw some numbers out here. What's the perimeter?
P equals
6
12.
plus 6 is 12 plus 3
15.
plus
8.
3,
18.
18 units.
Whoa.
By the way, we will use units. Sometimes I'll say centimeters, inches, meters, whatever. Make sure you keep your units with that or your answer won't be completely correct. Okay? Same thing with the star. If I gave you the lengths of each of its sides, we'd add them all up. Right?
Excuse me.
Bless you.
We all know it.
I think he's been screaming there.
Okay? What does area tell us?
The space
Space
inside.
inside. Space.
The space inside. Yes, the amount of space inside a figure. And it's the number of square units it encloses. If you were to put a grid on this, you could count all of the square units, and this will not be perfect, that's for dang sure. Right?
You just expect it not to be perfect.
Huh?
Like how you just expect it not to be perfect.
Well, it's not. Okay? Same thing if I were to put a grid through, like, this will look
Yeah, but
really...
there's gonna be like half the square in there.
Yeah, so you'd have some like half squares, you're right. So that's where it gets a little bit messy, but you could hypothetically find it, which is what we're going to talk about today. You know, there's 1, 2, 3, 4, a half, that kind of thing. We'll talk about all this in just a little bit. Are there questions on what perimeter is or what area is?
No.
No? Are you sure?
Yeah.
Next.
Wait.
Okay.
Ooh,
I'm waiting.
you can wait too if you pause the video.
I can't. Anyway.
Okay.
Am I good? Okay.
Space stuff.
So, perimeter and area formulas. I'm guessing you probably know most of these anyways, but for a rectangle, I would have a base height, or a base unit and a height. Perhaps you called them length and width before. Same thing. So to find the perimeter, if you wanted a shortcut to adding up all the sides, you take 2 of your base lengths plus 2 of your height lengths, and that'll give you the perimeter. You probably referred to it as length and width before. It's the same thing. 2 length plus 2 width will give you perimeter. Okay? How do you find area? Do you remember that? Length times width, base times height. Same thing. So there's the area formula for a rectangle. Same thing will work for a square, but with a square, you know that all sides are the same.
Yeah.
So you could actually shorten this up. For perimeter, there's 4 sides, they're all the same. Hey, where are you? There it is. 4 sides, they're all the same. You could take 4 times your side length. Okay. For area, you can do sides squared. Or you can do base times height. It would be the same thing. In this case, your base and your height for a square are the same. That's why we say sides squared. So for example, if these were 4, the side lengths are 4, we do 4 to the second power, which is
16.
16, thank you. So perimeter of a rectangle, perimeter and area of a rectangle, perimeter and area of a square. And then there's a circle. Circumference of a circle, which is again the units around. For circumference of a circle, I'm not really sure why that's not lined up. 2 times the radius times pi, or pi times diameter. 2 times the radius times pi, or your diameter times pi. It's the same thing. It just depends on, are you given the diameter or are you given the radius? This shouldn't be done like that. I don't know what's going on there. Alright. We're going to keep working with pi a lot. For most cases, we're just going to leave pi attached to it. We're not actually going to do 3.14 or multiply it in.
What's that?
This is the circle O, so this is like center O.
Okay.
And for area of a circle, we take the radius squared times pi. Again, I'm not really sure why that's offset, but radius squared times pi. So those are our formulas. Always, always, always square your units when you're talking about area. With perimeter, you would have whatever number of units. With area, you have units squared. So always square the units when we're talking about area. Questions on the formulas? Nothing new. You've seen those all before, right? It's been a little bit, but yes. Alright.
Yeah.
Alright, so using these with your neighbor, find the perimeter or the circumference and the area of each figure below. If you are watching the recording, now would be the time to pause. You guys can go ahead and work through it. I'll give you a couple minutes and then we'll do them together.
Yay.
So work together and find the perimeter and the area for each figure.
Explain to more.
Do this on the left side.
Left side, yes.
50, 56. That's right.
You don't need that.
Huh?
30 times 5.
So,
I don't know.
Not really trusting guys.
God, Aaron Cushing's Snap story was so funny.
I still feel like it's.
Anybody have Aaron Cushing on Snapchat? He's what do you call it? Bears with no teeth, and it was a picture of gummy bears.
Hey, what kind of surface do you have?
Alright. Even if you're not done, go ahead and work with me up here. How do I find the perimeter of this rectangle?
Just add the 20. Wait, do you add or you multiply?
Go add the 20. If I use the formula, I know some of you are probably like, okay, 20 plus 20 plus 8 plus 8.
That's what I did.
Perfectly fine, right? I'm totally good with that. Or to save yourself some time, 2 times 20 gives me 40, 2 times 8.
That's 10 of 56.
Okay. 56 what?
Inches.
Inches. Okay. I bet if you did 20 plus 20 plus 8 plus 8, you got 56 also, right?
No.
Yeah.
Yes.
Yes, you should have.
But
Okay. What about finding area here? How do I find the area of this rectangle?
don't you multiply like 20 times 8 or something?
Yeah.
Multiply 20 times 8. What do I get?
160.
160 what?
Inches.
Square
Squares.
inches. Okay, so that's how we write that. The area of that rectangle is 160 inches squared. Okay. What about for this square? How do you find the perimeter?
It's 28.
It's 28 because 4 times 7 is 28 what?
Feet.
Feet. Okay. For area?
27 to the 4.
7 squared, which is
49 squared.
49 square feet. Good job. Okay. Watch yourself when you do circumference. What am I given here? Diameter or radius? Diameter. So my diameter is 30 millimeters. What would my radius be?
15.
15. So keep that in mind because you need radius for area. Right? We will leave this in terms of pi, which means you're not going to actually multiply pi into it. The circumference formula was what again?
2r2
or
is
d
pi.
So 2 times the radius times pi, or, since I have diameter, diameter times pi. Okay?
So
So
30.
since it's diameter times pi, we're going to leave this in terms of pi. That's all I want you to write. 30 pi millimeters.
You don't want to actually do it.
I don't want you to type in 3.14 or hit the pi button. I just want 30 pi. Okay? As we continue through this semester and even into next semester, we're going to leave things in terms of pi, which means that essentially you're going to do all the math beforehand and stick pi at the end. Okay? Treat it like a variable, but it's not a variable. Pi is an actual number. Does that make sense?
It's a really long number.
It is a very long number. It's a never-ending number.
So why is it like?
We usually round
That
it.
just makes things really complicated.
I know.
Just round it.
We just round it. How do you find area of a circle? So you do radius squared, which is why I went ahead and wrote this out. Radius was 15. Radius squared, pi. So I just want you to figure out what 15 squared is.
15 times 15.
15 times 15 is,
225, I said it first.
good job. 225, stick pi at the end, so 225 pi millimeters squared. You guys good with?
Yeah, this is really simple.
Yeah.
This is really simple. This is like stuff I know you at least did in 7th grade, if not before that, right?
We actually went all the way before.
No, I never did this.
Once upon a time, I student taught in 7th grade, so I know at least you did this in 7th grade.
I never did this.
We learned this in first grade, but we didn't use it.
Okay? So, keeping those things in mind, we'll go to the
We
next
waited
slide
till we
here.
got to high school.
What if I give you a word problem?
Uh-oh.
I just skip it. No, you don't just skip it. You're gonna do this.
I will.
No, don't skip it.
No, don't skip it.
I give you a word problem. My suggestion with word problems, if it's at all possible, draw a picture.
With a 3.
Okay?
Thanks.
So this one says your pool is 15 feet wide and 20 feet long. What do I have? Likely a rectangle, right?
Square.
Probably not a square since they're two different lengths.
Yeah. That kind of
15 feet wide, 20 feet long, with a 3-foot deck surrounding it. You want to build a fence around the deck. How much fencing will you need? I'm gonna move this stuff all to the, oh, no, I'm not. I'm not moving that inside. We're gonna move some of this into the
It said
inside.
you know what else is 20 feet long.
We're gonna do it.
What?
So there is a deck
The
that
side of
goes
the pool.
all the way around. That is 3 feet wide. So there's 3 feet here, 3 feet here. You want a fence all the way around that.
Okay.
So if you include the deck, what's your new width? There's 3 feet here. There's 3 feet here.
Well, that would be 18 and 23.
But what about this side over here?
Oh no, it would be 26.
Yeah.
So it's not 18 here, it's
21.
21, right? Because there's 3 feet up
Plus
here,
the
there's
feet.
3 feet down here. So
And then 27.
I have an 18
Miss Newman.
foot width, yes,
Gotcha.
and a 26 foot length. How much fencing will you need? Now is the question asking for perimeter or area?
It is asking.
Perimeter, because we're doing fencing, right?
Yeah.
So how do I find perimeter of this giant rectangle?
That would be
2 times 26 and 18.
Yeah, doesn't matter which order you do it in.
26.
2 times 18, because you've got two sides that are 18 feet.
See how lag.
No, I thought it was
Yeah.
21.
Making you crazy?
It was 21.
Confusing.
You
Yikes.
said it was 21. Yes, that
right.
is Garrett Lewinstra that made that correction.
Good job, Garrett Lewinstra.
Good job. You're right. You guys did say that. 15 plus 3 plus 3 was 21.
Ooh.
Thank you. I'm glad you caught it.
21.
21. It's a horrible lag.
Is that the sum of 9 and 10?
42. There we go. Okay. 42 plus 52 gives me
God,
Yes.
94 feet. I need 94 feet of fencing. That's a word problem. If you remember on homework, I say answer your word problems with a sentence. That's not a sentence. How would I write that as a sentence?
You would need 94 feet of fencing.
For your backyard.
94 feet of fencing. Yep. To surround
Your deck.
pool and deck. Your pool and deck. That lag is gonna throw me off. Pool and deck. It's awful.
Is this because you're recording or is it always
Probably.
like this?
Well, duh.
Okay?
Don't dumb me.
Don't duh her.
Next
One
time
does
you do
right in
it,
the
tell me
face,
you
boy.
can sleep in the classroom as well.
They're really scary.
Cammy could beat Lou, like, not even kidding.
They're really
I
scary.
could.
Miss Newman, you should-
Okay, we'll try it.
So, the you try, if you could pause the video and take a second to try this,
Alright.
that would be awesome. I'll post the I'll post the answer with the notes later.
We're not doing it, Miss Newman.
Miss Newman, make
Next
that
slide.
face again.
Alright.
What? Oh, there's more?
So far it's been pretty easy. It's been rectangles, squares, circles, but what if I throw out this weird looking shape here? It's what we call irregular shapes.
She's like, sit down.
I get it.
Um,
Oh, it's fun. Can I break this?
if you have an irregular shape,
Hey, Miss Newman, can I break these shapes
we can.
into
We're gonna
shapes
get
I
there.
know?
Chill. We're gonna get there.
Chill.
Okay.
You
If
just
you
look at
have
one
two
up.
figures that are congruent, then their areas will also be equal. So keep that in mind. I'm hoping you're going, yeah, duh, that makes sense.
Yeah, duh, that totally
Okay.
makes sense.
But if you have an area of a region, it'll be the sum of their areas of its non-overlapping parts. That's where this postulate comes in to these irregular shapes here. So this is what they're referring to as a region. To find the area of this, you can add the non-overlapping parts. That's where I asked, can I break this into shapes that I know?
Yes.
Yes. Where would you break it?
Rectangle.
I would break
I
it.
would make a
break
rectangle
it into
and
a
a-
rectangle and a
a
square
square.
right
Here?
right yonder.
I don't know if that'll be a
Right
square,
there.
but, okay. Some people might choose to go this way. Totally fine, you're gonna get the same answer.
You can break it into three equal squares.
I'm not sure if they'll be equal, but you could break it into 3 parts, yes.
Yeah.
If you
Okay.
completely equal.
If I break it this way, I have a length of 16, right? So I've got a length of 16. What's my width gonna be?
Your width is gonna be
Your width is gonna be.
Well, the whole thing is
half
21.
of 21, not half of
It's not necessarily half. This whole thing is
21
21,
minus 8.
and this part is 8. So 21 minus 8 is
17.
Whoa,
No,
that's
that was way off.
it's full
13?
Yikes.
13, yeah.
13?
What's 21
Yikes.
minus 8?
Yikes.
13.
Spain, yikes.
Okay.
That's
So
a yikes.
if I want to find the area of this rectangle, what do I do?
That
You
is what we are.
base times height.
Base times height, 16 times 13. We'll come back to that. Alright? What about this part up here? I know, whoa, that was bad. I know that I have a side length of 8, but what's this distance?
That is
That is
Seven?
16. So
That's
16 minus
9.
7
16
is
minus 7.
9.
Hold on, it's 9.
9.
Alright, let me explain this. 16 is the entire length down here. If I were to shift this up, this is still 16, right?
Yeah.
But this part of it over here is 7. So 9 plus 7 gives me 16. So now to find the area of this one in blue, we take 8 times 9, right? What is 16 times 13?
Let me
Calculator.
get out my silicon. If does Mr. Rosen say? Anybody got that? Oh, that's funny.
16 times 13. How much?
Huh?
Oh, I thought you did it.
I can do it.
208.
Do I have a second on that? Why is that not right?
Yeah, he's right.
He's right. Okay. 208. What's 8 times 9?
That's 72.
72. So to find the entire area, I'm going to take 208 plus
Plus 72.
72.
Which is
Oh, I'm gonna do it.
280
280 what?
squares.
Units.
Units squared, because we were talking about area. Could you also find the perimeter of this guy?
Yeah.
You could, you don't
We'd
have
add
to.
some stuff up. Yeah, you're right. You could, but you don't have to. 16 plus 13 plus 7. You might have to.
Depends on what.
But for now, we're not gonna worry about that. Oops, wrong way.
What?
Okay.
What? What?
Whoa.
You're gonna do this one, Miss Molly,
That's
neighbor?
wrong.
Nice flower.
I just want to talk about really quick, how would you break this up? Lots of people do different things here.
I would
Break
do
it
a.
into 3 different rectangles.
Would you go like with a big one?
That
Like-
way and that way, yeah.
So you'd have a big, huge rectangle,
Yeah.
and then these 2 smaller ones?
Yeah.
You could do like a square and then the rectangles.
No.
Yeah, like
Luke.
that.
No, Luke.
Why?
You could go this way,
Because Luke, you can't do that.
okay? So then you have a couple,
You can
3
have
rectangles. Still have
I
3
don't care.
rectangles. Okay. We're not gonna do that one. I will post an answer when I post the actual notes. If you wanted to pause the video and take time to do it, you sure can. Same thing with this U try.
That's a flower.
Yeah.
Wow.
Whoa.
I am not doing that.
Whoa.
Yikes.
Whoa.
Ooh,
No.
actually, hold on. Let me go back to this one really quick. This one right here. I have seen where
Oh yeah.
some people will find the area of this whole thing, this 35 by 22, and subtract that one.
Yeah.
Which would also work. Okay? So you could do that. Which means that's kinda another way you could approach this one. You've got like a giant rectangle and you can subtract these parts right here and here. Alright? Again, I'll post the answer when I post the original or the actual notes for you. If you wanted to take time to do it now, you sure can. If not, we'll continue with the video. Are there questions though? Oh, I think I've got good
I
news
just got
on
one
that side.
question for you.
Watermelon.
Alright. Now, this is where we get into stuff that we're going to be dealing with over the next couple of days.
Okay.
We found perimeter, we found area, it's looked normal, it's what we've done, but now I'm throwing it on a coordinate plane. Okay?
How could you do that?
I know, it was so mean of
What
me.
did we do to deserve this?
Oh.
Math.
All we ever did was your
I made
math
some-
and
I made
find your
fiber
x's
shoes, that's what
and
we
not
did.
ask why.
I feel that what this will lead on to very good motivation.
Alright, to find the perimeter. Sometimes this is good news because I could likely count the distance of AB and I can count the distance of CB. Would you agree?
Yeah.
Yes.
Sure.
Well, let's do that really quick. From AB, I've got what? 1, 2, 3, 4, 5, 6 units. Do you agree? -1 to 5 is 6 units. 1, 2, 3, 4, 5, 6, 7, 8. 6 to -2 is 8 units. However, my problem lies with AC. I don't know the distance of AC. I can't just count the boxes. We're looking for perimeter, by the way.
We are.
So guess what I'm going to do?
Use the distance formula.
Use the distance formula. Remind me, what is it again?
That radical thing.
Radical.
x2 minus
x1 to
x1
the second power
quantity
plus
squared.
y2 minus x1.
y2 minus y1 quantity squared. Awesome. Alright, so let's find AC using the distance formula. We'll call this one x1, y1. Call this one x2, y2. x2 minus x1 quantity squared plus
That's
y2
36.
minus y1 quantity squared.
64.
5 minus -1,
36.
6 squared. 6 minus -2,
64.
8 squared. You're jumping ahead of yourself. 36, 6 squared is 36, 8 squared is 64.
That is 100.
What is the square root of 100? 10. Oh, that one came out nice. You're welcome.
Thank you.
Okay. Now, can I find the perimeter of ABC?
Yeah, it would be 24.
10
Units.
plus, I heard somebody, 10 plus 6 plus 8.
24.
24
Units.
what?
Units.
Units. And we're talking perimeter, so it's just units.
units.
Yes.
Unit.
Questions?
Unit.
This is where it all ties together, right?
Yeah.
Eh? Next.
Holy crap, how many are there?
That's a lot.
What?
Gary.
That was perfect for the recording. Yes, your homework is out of the Big Ideas book, page 34, numbers 7 through 15 odd, and then 17 through 24. You have a pretty good amount of time to work on it, or you should have a pretty good amount of time to work on it. Those of you in class, if you need to review the notes, these will be posted on YouTube. I'll post a link on my website. And the completed notes will be posted on my website as well. Okay? Alright, thank you guys.
You gonna listen to this now?
Wait, let me say goodbye to them. Hi, it's